Alright, good morning. This is a video to help with Math 140. This is suggested homework T1C, linear functions and special forms. The special form that we're going to look at in this problem is called slope-intercept form. Give me just one moment, sorry. This is called slope-intercept form. Slope-intercept form looks something like this. Y equals m times x plus b, where this guy is the slope. We'll come back and refer to that. And this guy right here is my y-intercept. Now I want to remind you, what does it mean to be the slope? To be the slope, that means that you're m. That means that you are the formula, you are rise over run. That means that you are y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? If you're to the y-intercept, then that means that basically that if you are on a graph of a coordinate plane, that you are somewhere on the y-axis. And if you are on the y-axis, that means that your x value will always be 0, because you haven't moved to the left and you haven't moved to the right, you just moved up or down. So if you're a y-intercept, then that means that you're going to let x be equal to 0. Okay, so let's go look at the problem we have here. All right. So what we're going to do is we're going to work through the problem using the guided solution to kind of help us. This is a similar problem to what people are having questions on. It tells us the formula for slope, so it walks us through. So we're going to sit here and say to ourselves, okay, we have the slope of a line. This is, I guess, if you want to refer this back to what we were just speaking of, this right here would be, we could call this, the way they have it listed, this is x1, and this is y1, and this is x2, and this is y2. Okay, now those are going to disappear now, but just so you can see that. So now as I go through here, I start plugging in my numbers. So y2 minus y1, there's y1, the 3. And then I have x2 minus x1. So we come down there, and that's a negative 2. When we simplify that solution, on top we get negative 13. On the bottom we get positive 4. So we're going to get a fraction, negative 13 over 4. The cool part about doing guided solution is that you can click check, and we got something wrong. So let's go take a look where they say we got it wrong. Okay, so it was in our fraction there. So let's see if we can change that answer around to get something they want. Okay, let's see. So let's see, maybe what we did is they don't like the negative sign right there. So let's delete that. Let's go out in front. Let's put our negative right there, and let's put 13 right there, and let's check it now. And I don't know why it's not going anywhere. Let me hit pause and be right back. Holy moly, that's slightly embarrassing. I'm going to go ahead and move forward with the video, but I see what my problem is that I clicked you tried again, or tried again, and still I had the wrong answer. So it wasn't where the negative sign is, it's the fact that that's 16, Josh. That's not 13, that's 16. So let's just put the negative up there on top again, and let's go out front, and I want to delete that negative. Okay, and let's click. Okay, great, we got it right that time. So that which simplifies to negative 4. All right, so now it says, note you could have used any of the 3 points or simply counted the change in y over the change in x. So what they're saying is that little symbol right there, that delta is what it's called, it's a Greek symbol. That means change. So what they're saying is that you had these points, and that if you would have counted your slope, and we'll go ahead and do that, let's take a pen here. If we would have counted our slope, and we would have started, let's say at this point, let's use red instead. Let's say we started at this point and go to that point. So remember, slope is rise over run. So we could see that we would go from that point, this would be let's see how we should do this. Let's go. That's 1, 2, 3, 4, 5, 6, 7, 8. So I have a rise of 8, and I have a run of 1, 2. Now the thing is I didn't go in the positive direction when I ran, so I ran a negative 2. So if I put that into my equation, my raise was 8, my run was negative 2, and when I simplify that, I find that my slope is negative 4. Alright, so let's go back down here. They say, so by inspection of the graph, we can identify the y-intercept. Okay, so one thing we can do is, at this point, is we can say to ourselves, our y-intercept, like I said in my previous page, my y-intercept is basically when x is equal to 0. It's somewhere on the y-axis. So I come up here and I notice, oh, there's x equals 0, so my y-intercept is at 0, negative 5. 0, negative 5. Check myself. Okay, great. Now this goes back to my equation a minute ago, and I'm going to go back to that slide one more time. So if you'll remember that when I'm in slope-intercept form, my slope goes in front of my x. It's y equals slope times x plus y-intercept. So in this case right here, we found out that our slope was negative 4, and our y-intercept was negative 5, and there we go. We have the equation of our line. So hopefully that will help you with slope-intercept form and how to go through the process and connect.